Today we're going to learn about compiling a program in C in the Unix environment or the Linux environment. So the first thing I'm going to do is open a file. I'm going to use nano for that. Nano, and I'm going to call the file, I'm going to make a file now, file.c. And now I have a file, and I would want to type something like, int and, printf is the best way to print in a C, or one way at least. Now printf, I can just type, for example, hello. Now printf is a function. In order for this function to be recognized, I'm going to need to have it include. Wait, I need to write int main. And I'm going to have to do here, let's try return 0. And I need to have some includes. Now, let's say I don't know what include to have for printf, that function. That function is written in a library somewhere, and I need to include that library. So let's exit from here. And let's do man printf. And now it should show me the manual page for printf. Now this is not the manual page I'm interested in. This is, if you notice, there's a 1 over here. That means it's in manual chapter 1, which is commands. I want to get the function, so that's going to be the C function. That's going to be in chapter 3. Now the way the manual works is if there's multiple entries in the manual page, it'll show me the first one. So in this case, printf appears in chapter 1 and chapter 3. I need to specify chapter 3. So, because I'm interested in chapter 3, the way I do that is I write a 3 here. That means chapter 3. And now it gives me the printf function. You see printf here. And it tells me that the include I need to have is include std standard IO. So now I know what I have to include for my program to work. I'm going to exit the manual with the button Q. See, it says in the bottom, Q or quit. So I type Q and I reopen my file with nano. And I pasted too much. That's interesting. Okay. I thought I could paste it in. Int main. And I'm going to type it in now. So I have to do include standard io.h. And now I've got my include. I have my main function. In that function, I call the function called printf, which is included, which is a function defined in this library, and it's going to print hello. Maybe we want it to print, okay. So now I will save my file, and I'll compile. How do I compile? I use the GCC compiler. Now I just type GCC, that's the GNU C compiler, that's what it stands for, GCC, GNU C compiler, and I type the name of the file that I want to compile. Now it didn't write anything on the screen, that means it succeeded. So now I want to see, I want to run it. What is the name of the compiled version? So if I type ls, which lists me all the files, -l in long form, reverse time. That's going to show me the most recent at the bottom. So now I see all the files, and I see the most recent file is at the bottom is a.out. Here's my file.c, and here's my what is this a.out? That a.out is the compiled version of my file.c. You see, it's much bigger. This is 62 bytes. This is 16,000 bytes. Much bigger. Because it included everything necessary for that printf to work. So now we can run it. How do we run it? Well, basically just type the name of the a dot out. This is probably not going to work if I just type it like that, because it doesn't know where a dot out is, even though it's right here. So I have to tell it it's right here. So the way I do that is I type dot slash. That means dot means right here, and in slash means underneath right here. And it's underneath in this directory. Look for a file called a.out. If I run it, it prints hello. See the hello over on the left there? Now, that's not exactly the way I want it to print. Let's improve it. So I want it to print hello world. And I want it to have a new line. The way I get a new line is I type \n, not a forward slash, a \n, new line. N stands for new line. Now I have to save it. Yes. And how to use Nano, you can look on the web instructions. I do Control S to save, Control X to edit, to exit. So now I want to compile it again. I'm going to type GCC. I can use the up arrows to get the previous command, the up arrows. So I do up arrow until I get to GCC file.c, and I compile it a second time, and I run it a second time. Now it's going to print hello world and then a new line. That's still, now I'll show you another thing I want to show you, which is I can give a name, instead of calling it a.out, which is the default name that every program will get when you compile it, I might want to give it a specific name. If I want to give the compiled version of my program a name, I'm going to type -o for output file, and then I give the output file the name I want. Let's call it program 1. Here I can call it whatever I want. I don't need extensions like .c or .anything. I can just call it whatever I want. I could write a .anything. So I'm going to call it program 1. That's a little bit confusing because it's different from the name of the file. So let's call it file. Now it's the same. Now when I compile it, if I do ls-lrt again, now we see under a.out, there's another file called file. And that is our output file. Notice it's the exact same number of bytes as a.out because it's the same program essentially. Both of them are the compiled versions of file.c. Now it's in a compiled format that I can run, and both of them, a.out and file. So I can choose either one. I'm going to choose file this time instead of a.out. I'm going to do file, and it says hello world. So we've now seen that how to compile a simple program that says hello world. Now I may want to do something more in my program. Let's do something more interesting. And let's use a special command, a special function called fork. Now what fork does is it makes two processes run simultaneously. So once this fork command is run, there'll be two different processes running simultaneously that will be printing whatever comes next, however many lines. In this case, only one line, hello world. The return just ends the program. So if I save it, and now I compile it again, and it tells me fork, implicit declaration of function fork. In other words, I'm declaring it fork as though it's a new function, but it's actually, I didn't want to declare it. I didn't define that function. What does it do? So the truth is I didn't want to define it. I wanted to use the library function fork. So I have to find it in the library. So I'll do man fork. And it tells me that I need two includes. I need system types and UNIX standard. Let's see if my cut and paste works this time. Nope, doesn't work. I don't know why. So I have to type it. Include was it, sys slash types dot h, and include UNIX no, what is it? Is it UNIX? UNIX std dot h. How are we going to know if we get that right? I don't think it's with an X there. Let's see. Sys, let's check that again. Sys types.h, but here it's uni standard. Good. Quit to get out. Let's fix that up. Uni standard. Okay. And now the fork should work. Let's see if the compiling. Yes. And let's compile it. If it's quiet like that with no error messages, then we know everything worked. So let's run it. And it printed hello world twice. Why? If you look at our program, it only says to print hello world once. The answer is because we have two programs running simultaneously. We said fork right here. If I put the fork after, is it going to also print twice? Sorry. Fork. And if I run it now, I have to compile it, run it, and it only prints once. Why? I also made two processes. So let's look at that program again. The answer is that I made two processes, but only at the end, after I printed. At first I printed it, and then I said make two processes. But I made two processes, but they just ended. It should return 0, which is the end. So that fork didn't really achieve anything. Only if I put it before whatever I want to do twice will it achieve something. Now, what if I want only one of the processes to print hello world? So for example, I want just we're going to call the one that I created, the original one is the parent, and the one that he created by the fork, the second process, is the child. Now there's the second running of the program. So I'll do something like this. I'll write integer, a variable, and I'll call it PID for process ID number. And I'll say PID equals fork. So PID equals fork. So now fork is an interesting function. It returns a value. It returns either 0 or 1. And sorry, not either 0 or 1. It returns either 0. It returns 0 to the child process, but to the parent process, it returns the PID of the child, the process ID. It's as though a woman gave birth in a hospital, and at the time of the birth, the Minister of Interior comes and gives her the identification number, the citizen identification number for the child. But the child gets 0. He gets nothing. The child gets nothing. The parent who created the child gets the identification number of the child. So if I would write, for example, if, and just the PID, let's say like this, is not equal to 0, then what can I say is true? So let's make a comment, which will be ignored by the compiler. Well, who am I here? If the PID is not 0, all right, I got a PID. If it's not 0, it's some number. Who am I? I must be the parent. Notice it's in blue because it's, I forgot to write a parentheses, although in this case I don't need it, but I'll write one. There, parentheses. And now I can write else, and also write parentheses. braces they're actually called. Else, well, I'll do print f. Who I can write, I am the child, right? Because here it is 0, and we said the child got 0. So here's going to print I am the child, new line, \n, quotation marks, the end of the string that I want to print. And every line, every command has to end with a semicolon. So if I'm the parent, because my the PID by this version of the program is 0, then it'll print hello world. But if I'm the child, so which is it going to print? This or this? Well, let's see. Now to save, I can just do Control S. And then Control X to exit. Now, if I compile it again, now let's see. We asked our question, which one will it print? It printed both. Why did it print both? Because I have 2 processes running simultaneously. One printed the hello world, that was the father, and the child printed I am the child. Now, if I run this many times, I might see that the child prints first, but it doesn't, because it takes time to create the child process. And in that time, the parent process already printed hello world. So that is already interesting, that I can create 2 processes around the same time. Now, what if I want to print the PID? I use the symbol %d, and %d means I want to put a number in this location. What number do I want to put in location? So after the quotation ends, I write a comma, and then I can write the variable that I want to be printed where that %d is. So in this case, I'm going to write PID. So the parent is going to write the PID of his child, right? What will the child write? Well, the child, I am the child, and let's say his PID, not D, what PID? He doesn't know his PID. The parent has this PID value. He's just got 0. If I would write PID here, I would get a 0. I want to write my PID again. I'm the child. I want to know my PID. Get is a function called getPID, which returns the value of my process identification number, PID, process identification number. So the child's identification number will be returned to the child here, and he'll print it in this D. What about the parent? The parent will print also the child's one, because he got that from the fork. He's not going to print his own. If I wanted to print the parent's own, I'd also write get PID over here. He's going to print his child. So when we run this, we should see the same number, PID. The same number should be printed by the parent, which is the child's PID, as the child when he says, give me my PID. So let's compile that. And you see hello world 298, 298. They're both the same because the father printed the child's, and the child printed his own PID. Now, there's another function I want to show you right now called the sleep function. Remember we said that the parent will always print this first because it takes time to create the child. What if I want to slow the parent down? So I can put him to sleep, which means he does nothing. And I can say sleep for 1 second. Now, when I save it and I compile it and I run it, I see I'm the child got printed first, and then hello world 306. Now, there's another way actually to do this, because the sleep is it's considered ugly in programming, because what if it took more than a second to create the child process? How do I know? It's sort of an arbitrary number. Well, who says that 1 second is enough. And if I write a bigger number, maybe it's enough one time, but another time it's not enough. It's considered an ugly way to do things because it's not necessarily going to work. It's called a race condition. It's only if this slows me down enough and I lose the race. But in any race, you never know who's going to win. So it's called a race condition. It's not a good way. A better way is for the parent to wait for the child to finish. So for that, we have a special command called wait. But it takes a parameter. I'm not interested in this parameter, but I've got to give it to it. It takes a reference parameter. So now I have to define that. So I'll define it over here. Int. I have an integer called PID, and I'll make another one called status. I'm not going to use this one. That's just the way I have to do it. That's the requirement of using this function. I have to give it a reference to an integer. So what does this do? This says wait. Now even though the function is called wait, really what it should be called maybe is wait child. I'm waiting for one of my childs to do what? To finish. So this will print I am the child. And then the child will finish, and then he'll print hello world. So in other words, this wait will stop the parent from running until the child has finished his job. This is a message passing system. The operating system automatically sends a message to the parent whenever one of his children finishes or dies. So now let's recompile it. I might need a new library. Let's see. Yes, implicit declaration of function wait. In other words, I didn't define it. So I have to find out where wait is. So let's do man wait. And it tells me that wait is in system wait. And system types I have already. But if I didn't, I would have to type that also. But system wait. Okay, so no problem. Let's go back to our program. And let's type in include sys wait I suppose it's that H. Was it really that H? Let's see that again. Yeah. Q to get out of the manual. Now let's compile it. Compiles perfectly. And let's run it. It says, I am the child, hello world. So it's the child printed first again. The parent was waiting, but without a sleep, but with the wait command. That's considered more beautiful than any other way of doing it. It's like the correct way of doing it because you're actually waiting for a signal to be sent by the operating system to indicate that the child is finished, and then the parent will print hello world. So that's a nice little program. I showed you how to compile. I showed you how to write a small program. I showed you how to fork your program. I showed you how to have one process wait for the other process to complete. And that's a good introduction to C programming in the Unix environment.